Good afternoon, ladies and gentlemen, here in Silicon Valley, here at the Santa Clara Convention Center. Good morning, good afternoon, good evening, if you're watching this out there on the World Wide Web via SYS-CON TV and those 1.8 million pages that we embed this in, streaming it live. If the cloud were a color, I suppose it would be hot pink. If the cloud were an animal, it would be, I don't know, you're going to hear all of this, I'm sure. Is it going to be a tiger or a roaring lion or who knows what? I'm not going to go into the hyperbole stakes because there's too much of that around. Cloud Expo, as you know, is solidly based on content. So we've got these 8 tracks. If that's too many, I know you're going to tell me during this show over the 4 days, Jeremy, that is too many tracks. This is too much cloud. Please do. You know how to get to me. You'll see a lot of me, hear a lot of me. Otherwise, you all know where to find me on Twitter or by email. Feedback is king. Cloud is emperor. So we're going to hand over to Oracle. We're going to hand over to Mohamad Afshar, who's going to introduce... Oh, we're not. We're going to hand over to Mike, who's going to introduce Mohamad later. Please give it up for Oracle. We'll talk again later. Guys, get into it.
Thanks, Jeremy. Pink. Come on, clearly the color is red. Welcome on behalf of Oracle and Cloud Expo. It's really wild to see at least a tripling of this crowd since we did this last year. So obviously things have changed a little bit when it comes to cloud. I'm Mike Peachy, Director of Product Marketing with Oracle Fusion Middleware. And I will be joined shortly by my colleague, Dr. Mohamad Afshar, Vice President of Product Management, also with Oracle Fusion Middleware. And Hassan Rizvi sends his apologies for not being able to make it today, but hopefully we'll keep you at least somewhat entertained in his stead. So like most cloud presentations these days, the obvious place to start is with yet another definition. But rather than just go into a PowerPoint version of that definition, we thought we'd complement it with the words of some folks on the street. So let's take a look at what a few random folks around San Francisco had to say about this.
I can tell you what it isn't. It isn't God using a computer up in the cloud. What it is people accessing their IT services from anywhere, from any device.
It's really just sort of the next wave of putting applications and devices into the hands of people where they need it, as opposed to being tied to specific infrastructure, locations, those kinds of things.
Cloud computing actually happened a few years ago, came out when all the airlines started allowing users to use Wi-Fi up when they're flying through the clouds.
The cloud offers something that has never existed before, which is elasticity in both directions, i.e. you can grow your data center to whatever size you need, and you can also shrink it.
It's a new way of doing a business altogether.
It's a buzzword right now, and it'll probably stop being the buzzword, and it'll just start being what computing is known as.
Providing a service that has a clear line of ownership, and that clear line defines an SLA. And that's basically it in a nutshell.
Oh, it's up into the stratosphere. It's as high as the imaginations of these brilliant engineers will go.
So, a few interesting thoughts on what might constitute an interesting definition of cloud computing. So, for the moment, let's maybe all level set with at least one fairly well-respected definition out there coming from the National Institute of Standards. And they say that cloud computing is a model for enabling convenient, on-demand network access to a shared pool of configurable resources. They talk about rapidly provisioned, minimal management, and you can read a couple of the other essential characteristics there. By the very fact that you're in this room, you're probably already familiar with the different layers at which cloud is defined. Software as a service, platform as a service, infrastructure as a service. I won't belabor the details of that distinction. The NIST definition also talks about 4 different deployment models, public and private, and a hybrid, and community cloud. Now, just again, as evidenced by the fact that there are at least 3 times as many people in this room as there were at the same conference a year ago, it's not news to you that cloud is exploding. As another indicator of that, this study here, this survey done by the Gartner CIO agenda for 2010 shows cloud computing having leapt from number 16 in 2009 to number 2 in terms of priority on CIOs' minds, just below virtualization, which itself jumped up. And a very interesting statistic also, this came from a CIO summit that we did at Oracle a few months ago. This quizzed the folks in the room on the different cloud models and how they were putting those into play. And so these are senior IT leaders, CIOs, and such. And basically 90% of them were doing some sort of private cloud, whether in a hybrid model or pure private cloud. So basically only 10% of the enterprise folks in the room were going in a pure public cloud model. Now, that's enterprises, and that's a certain sector of the market and so on, but the real point here is that there's a lot of significant activity going on the private cloud front. And within the world of private cloud, it's interesting to note the direction that enterprises are going. A few years ago, as folks were first starting to get started with this, you saw a great emphasis on infrastructure as a service, basically cloud enabling the lowest layers of the stack. At this point now, platform as a service has surpassed infrastructure as a service in terms of focus of internal cloud development. And the most popular applications to be cloud enabled and put into in a platform kind of configuration within the enterprise are the application server and the database. So while just having built that case and hopefully calibrating a sense of the emphasis that's being put on private cloud out there in the world of big businesses, we also recognize that there's a lot of activity going on in the public cloud. A lot of important applications are making their way into public cloud infrastructures, and we very much support that as well. Among the obvious and still most significant reasons why many enterprises might look at public cloud with a bit of trepidation are boil down to control over destiny, control over quality of service, control over security, and total costs over a lifetime. And the response to those sorts of challenges is, in some cases, maybe to just put non-mission critical apps out there on the public cloud, just stay purely with private cloud, kind of wait and see. And certainly the industry is evolving, and many different ways of addressing those challenges will continue to evolve on the public cloud front. In other cases, the important challenges are integration with legacy, with your existing applications and infrastructure, as well as cloud-friendly packaging of the applications or middleware or database software that you might be considering putting in the cloud. Response to that challenge is to put the right software in the cloud. Use the right software when you're trying to set up your public cloud deployment. And so I wanted to highlight here a couple of different ways in which Oracle is making substantial efforts to do exactly that. So first of all, for folks who aren't aware of this, most of the Oracle product offering, the software that you think of as that traditional enterprise industrial strength software, is packaged up and licensable and ready to go out there in the cloud. So for example, for Amazon EC2, the entire Oracle stack, from the virtual machine through operating system database, up through applications such as eBusiness Suite and Siebel. Fully supported with Unbreakable Linux and the Amazon Premium support, and first-class citizen relationship with the Oracle Linux, the virtual machine template format. And as another example of a packaging for public cloud-friendly deployments is a partnership that we've done with SYS. And this is getting up underway now, and definitely I believe they're here. Have a chat with them at their booth as well as us at our booth. But we've got some very interesting platform as a service offerings jointly there with SYS. And so now to dive into what does it take to actually build a cloud infrastructure, whether you're an enterprise wanting to do a private cloud, whether you're a provider wanting to provide a public cloud service to your customers, or whether you're wanting to do something of a hybrid nature. What does it take to actually build one of these? So let me introduce my colleague, Dr. Afshar, to take you through some of that.
Thank you, Mike. Thank you. Wonderful. Pleasure to be with you again. It's been a few months since we were together in New York, and I think a lot of things have changed at Oracle, certainly, with the launch of the Exalogic Elastic Cloud, which I'll talk about momentarily. Before I do that, I just wanted to recap some of the things that we've heard from customers. You know, when you think about the way enterprise IT operates, we're generally under a lot of pressure. We have to deliver SLAs, like you heard in that video at the beginning, SLAs to a contract. You have to be able to grow and shrink capacity. But we've got a lot of IT pressure. There's always a pressure to reduce costs, and everybody's trying to reduce the amount of IT burden that there is on the business. So there's a tremendous stress to simplify the IT environment. But at the same time, we know what business wants, so we know realistically that many people out there who are on the line of business side love the concept of cloud computing in general, because it delivers for them the ability to get services on demand, whether that's a box of hardware, whether that's storage, whether that's a platform as a service, and all they want to do is buy an SLA. So specifically for many of you out there who may be looking at a private cloud environment or a data center environment, what are some of the approaches which you can take to address these kind of challenges? Well, of course, we can carry on doing things in exactly the same way we used to before, which is we have a project, we get some software, get some hardware, put it out there, and get it working, right? And whether that happens in our own data center or in the cloud, the challenges are pretty similar in the sense that we have a very disparate IT environment that's pretty hard to integrate. Because we have these silos, it can be difficult to get good utilization. And there's a tremendous amount of building still involved. You have to put all the pieces together, whether it's the middleware pieces and the database pieces and the operating systems and the storage. So it can be a very time-consuming way of building systems. But that's what we've been doing for a long time within IT. And of course, virtualization is a great technology because what it enables us to do, which is really to take another approach, which is to have a layer of infrastructure, whether it's servers and storage and network, that enables us to drop our applications and run them on top of this environment. However, some of the challenges we're starting to see with that is that many of our very large customers are ending up with environments with thousands and thousands of virtual machines. So provisioning and managing all these virtual machines is becoming a real problem because they're not really in logical units of what an application would look like. And of course, in this world where we have big pools of virtualized infrastructure, monitoring and management becomes really hard. Trying to do root cause analysis on specific problems that your application may be subject to is quite easy in the siloed world, much harder in this world of horizontal layers. And of course, there's still lots of building to do, because you have to build the infrastructure out on which you can host your applications. And that's really the point, which is all these approaches require a tremendous amount of work. Whether it's setting up your storage with your operating system, setting up your servers, getting space in the data center, getting the light SLAs for your networking infrastructure, all of that takes a tremendous amount of work. So what really our vision is to do as much of the work for you as possible by delivering systems in which there is much less assembly required. And we're not just talking about systems with storage, we're not just talking about systems with compute, we're not just talking about systems with virtualization, but we're talking about systems that have middleware and database already pre-engineered to work together in a consistent way. And what the net effect of that is to enable you to get a much higher quality product. So if I'm a Formula One driver sitting in that car, I don't have to worry about all that engineering that went on in that car. But I know that car is specifically engineered for a specific task. And that is really the notion. When we talk about engineered systems, that is exactly our vision for driving the next generation of enterprise IT environments through this concept of engineered systems. And we fundamentally believe that this marks a huge change in the way IT is done. And to think about it in your own world. If any of you have to set up environments for projects, think about how long it takes to spec out the software, to spec out what hardware requirement, to put it through a requisition process, to get the hardware in, to get it configured, and then to lay down all the software bits on it. Our vision of engineered systems is to give you that enterprise private cloud delivered in a way where much of that work is really done by us. So you might ask, does this actually work? And what are the net effects of it? And I want to share with you some data points. 17% performance improvement with customers who are using our Exadata database machine. 1.3 million customers serviced. Ability to support innovation. Much faster than IBM P series. I had to put that in, didn't I? Query results 4 times improvement. 100 times scale. Database as a service. And probably the most notable of this is seeing processing times drop from hours to minutes. And that's really the key idea here. Because what it is not about putting software in a box and shipping it. It's about fundamentally changing the way that the software works with that hardware environment. It's about balancing the hardware architecture. It's about doing some very smart things in the software to utilize the hardware available within that environment. So let's specifically look at what it takes to build cloud infrastructure. We really believe this concept of engineered systems and engineered foundation is critical. And I'll talk a lot more about that in a second. But of course, some of the other factors that we know everybody's concerned about, business especially, is can I get systems as quickly as possible? Will you deliver elastic capacity for me? Is it all secure? Because we know that's one of the biggest barriers to cloud adoption. And do you have self-service built in to every layer? So let's talk about that engineered foundation, and specifically one of the products we delivered about 2 years ago, which is Oracle's Exadata machine. And obviously there's a lot of bells and whistles to keep all us propeller heads really busy and thinking in terms of the specs on this environment. But let me tell you a little bit about some of the real innovations that we've delivered within this environment. Technologies such as Smart Cache, which basically enable you to utilize Flash in order to deliver much better database performance, not only for data warehousing, but also for online transaction processing applications. Technologies that actually you may be familiar with from the web world, which involve pushing database operations onto the disk controllers as much as possible to parallelize the reads that are coming through the environment. So what we've really done is looked at how the software operates and tried to take a lot of the innovations that we see in the software world around highly scalable systems and really bake that into our database within the context of Exadata. And one really important thing is that you don't have to change your applications to benefit from this kind of performance. You do not have to change your applications. So the same way in which you've developed your applications, whether it's your own custom applications, whether it's our applications, they run super fast on this kind of hardware platform. And that's really one of the recurrent themes you can expect to hear from us, this concept of really giving you the ability to adopt these kind of cloud computing technologies without having to make fundamental changes in some of the ways that you do things. So let me talk about a product that we just released at OpenWorld, which is the Oracle Exalogic Elastic Cloud. So what did we do here? We took the same concept of engineered systems and we thought, if we wanted to build a very highly scalable, highly performant infrastructure to run Java applications, what would that look like? So we started looking and we realized, okay, well, networking is one of the areas where Java applications tend to be network bound. So what can we do to address that? So we put an InfiniBand network within this infrastructure. Database connectivity is one of the other areas from an I/O perspective where application performance can be improved. So what did we do? We gave native InfiniBand connectivity between this Exalogic Elastic Cloud and the Oracle Exadata machine. And what the net effect of this engineering work, and we've done many other things within that context, is to give you the levels of performance that you could not expect to deliver even if you put thousands of machines together yourself. So these are a few benchmarks which I wanted to share with you. The ability on one of these machines to handle 1 million HTTP requests a second. So simple, inbound, outbound. Significant improvement in messaging applications, and of course, significant improvement in database connectivity. So for those of you who are thinking about consolidating your data center infrastructure, thinking about potentially reducing your hardware footprint, this kind of solution enables you to consolidate many of your applications onto a single hardware environment. And the key thing is that it's pre-engineered to work together. That means it works from day one, out of the box, pre-configured. It runs Java super fast, but it can run any kind of application infrastructure. And management is clearly a key consideration. So any kind of cloud foundation needs to give you the ability to set up the infrastructure, to partition the infrastructure between different users or different lines of business, which includes all the way down to the storage and the network. The ability to build logical units, which are application components as platform or PaaS components that you can deploy. The ability to set up policies with respect to users, with respect to dynamic resource management, to deploy, and of course to patch. Because one of the things people like about the public cloud is you don't have to patch things very often. Somebody else does it for you. Where really we can deliver the same kind of concept through this one patch concept for our engineered systems. And of course you want to be able to monitor, which is I want to know what the business impact of specific things that are going on in my infrastructure are. So if my CPU is 50% used, does that tell me my transactions are taking less time or more time? Or how much less time? And these are some of the things that you need to do in order to be able to correlate business metrics together with systems metrics. And of course, you have to be able to scale up and scale down as well as decommission infrastructure. So the management capabilities within a cloud infrastructure, whether it's a public cloud infrastructure or a private cloud infrastructure, are really critical to that cloud foundation. And I just want to touch upon one of those, and you're going to be seeing a demo of this in a few minutes, but this concept of assemblies. So if you think about many of you who thinking about deploying systems generally do not consist of one application infrastructure. They have databases, they have middleware components, they have messaging infrastructure. And of course, if you want to replicate an entire system with all of the configuration out of the box, it's actually a pretty hard thing to do. So what we've done within this infrastructure is really develop this capability called Assembly Builder that will enable you to introspect an existing environment. It will capture all the metadata associated with that, and then it will capture that assembly, put it into a repository, and enable you to replicate the very same environment. And when I say the very same environment, I mean from a configuration perspective. I don't mean the same number of servers, because that information can be dynamically changed at runtime. What this kind of framework allows you to do is to significantly take out errors and mistakes and configuration problems that many people have when you're building out systems. Cloud is about elasticity. And the elasticity is not just at the VM layer. Clearly, we can spawn out VMs to spin up extra database servers, provision additional storage for ourselves. But one of the key things is your infrastructure has to be very smart around what to scale. So within the mid-tier world, many mid-tier applications are memory-bound, right? So the inclusion of things like a data grid within this architecture or within the elasticity architecture enables you to scale applications in the appropriate way based on specific demands that are being sensed. So a critical idea here is that elasticity is not just about spawning up virtual machines, but it's about being very smart about what capabilities need to be spun up. And the only way you know that is by having the cloud foundation or the cloud management earlier to enable you to provision those kind of environments out. Security is one of those topics that obviously it's very topical within cloud computing, and that's one of the biggest concerns within certainly the executive audience as it relates to cloud adoption. So let's talk through some of the issues that typically occur around security and talk through some of the solutions. First of all, obviously, if we're going to put our data in a shared environment, whether it's the public cloud or the private cloud, we want to make sure it's encrypted, right? Secondly, if we're going to back up our data, whether it's to tape or to other tiered storage, we also want to make sure that is encrypted as well and is backed up in the appropriate way. From a management perspective, we want to make sure that the people who administer databases have segregation of duties, so that if it's on salaries or organizational structures or social security numbers, people like DBAs don't have access to that kind of information, and there's segregation between different people. And also from an audit perspective, you want to be able to produce reports for HIPAA, SOX, etc. And finally, you want to be able to protect your database transactions or certainly SQL queries going back and forth on the wire. So you want to be able to do things like syntactic and semantic reviews of those SQL statements that are going back and forth to ensure that you're not subject to SQL injection attacks. So if you look at the data security problem, we talked about one aspect which is really related, or security problem is related to data security. But let's talk about the identity, or rather managing identities within the context of a cloud environment. So if you think about many organizations today, they're using both in-house systems as well as cloud-based systems. And what you want to be able to do is to do a few specific things. First thing is you want to be able to provision people within your enterprise into an external cloud resource based on specific entitlements and roles and specific entitlements associated with those. Secondly, you want to be able to have the approval work steps or workflows associated with that so that the right people have access to right systems and you have a certain set of auditable policies that you go through in order to do that. And of course, you also want to be able to go the other way around, which is to be able to take potential identities from the cloud-based environment and federate them to within the enterprise. So when you're thinking about cloud-based environments, as you evolve to an architecture where you have using public cloud services as well as private cloud services, the notion of managing identities, federating them, being able to provision them based on policies into your network as well as into public cloud services is a key consideration. So self-service is clearly one of the key requirements around cloud computing. And really when we think about this, we think about the context in multiple contexts. The first one is many applications today are developed in Java EE, for example, and those applications are developed and deployed. But much of the time, business users want to be able to change those applications. They want to be able to change the data structures, maybe add an extra field. They want to be able to change some of the business processes, maybe add extra steps within those business processes. They want to be able to embed analytics, and they want to change the look and feel of those systems. And much of the time, this requires a lot of change in code. So it requires developers to make changes to the systems. So one of the innovations that we're bringing out to market is really the notion that you have self-service and empowerment in the hands of the business user. So when applications are developed and deployed using this kind of environment, business users have the ability to change their business processes, to change the analytic reports that they get, to change the data composition or add extra data fields in the context of their applications. And more importantly, they can do all of this using metadata. And what that really means is that they are safe from the perspective of patches being applied and from the perspective of upgrades, because the metadata is kept absolutely separate between their own metadata and the back-end application metadata. So again, one of the key concepts really around this next-generation cloud computing infrastructure is the ability to have self-service environments, and some of the ideas that we bringing to market around composers is really bringing that both to the private cloud environments as well as to the public cloud environments. So we talked a little bit about some of the key enablers for cloud computing, and certainly we worked through the engineered systems idea, the ability to deploy systems very quickly, ability to add and remove capacity, security, and self-service. But I want to take a few minutes to talk you through some of the key ideas that we certainly believe in as we're thinking through this evolution. First thing is, we fundamentally believe that customers should have choice about whether they should go for private cloud computing environments or public cloud environments. And that's really what we're doing. We're supporting our software both in the context of public cloud, so we have customers such as Advanced Innovations that are running things like e-business suite and Web Center and our service-based infrastructure, all on EC2. But at the same time, we want to be able to deliver, and we are delivering, integrated engineered systems that enable you to build private cloud infrastructure in a more cost-effective way. The second key thing that we're really doing is around giving you ease of adoption. We don't fundamentally believe that you need to make significant changes to your applications. You shouldn't have to make significant changes to your application to benefit from cloud computing infrastructure, to be able to benefit from some of the capabilities that we've shown here today. So the notion of engineered systems, the notion of these systems delivering some of the performance and the availability that we've delivered, enable you to take your existing applications and really benefit from the scale-out architecture that the cloud computing world brings to the table. And then finally, we fundamentally believe that security and performance are key things that have to be delivered in the context of cloud computing in general, whether it's public or private cloud computing. And that's really what our focus is really around this notion of delivering all of these through these engineered systems. So thank you very much. Thank you for your time.